Thank you very much. Good morning, everybody. Thank you very much for inviting me here, and thank you for listening. So, today we will look at human-computer interaction and virtual reality for different applications. So, I will show many different applications for virtual reality and HCI, human-computer interaction. So, one of the advantages of virtual reality is many times we do not have a lot of space. Many universities in the US and in many other countries have limited space and limited money. So with virtual reality, we created many different 3D applications for safety and for limited budget and for space. And so I'll show you different applications that have been created using virtual reality. And the graphics-based interaction, so how the user can interact with the data and with the 3D worlds. So every application is different. So when we create a 3D world for an application, the virtual reality and the human-computer interaction must be suitable for that application. So for example, for GIS, the objective, the goals are different from mechanical engineering. It is different from mathematics. It is different from physics. So for each application, first we must understand the need for the use of virtual reality, and then we must develop the graphics design for that. So with 3D visualization, we can create situation where we cannot see in the real world. Like we can get very small and get inside something very small, like say nanotechnology or atomic structure or chemical molecules. And if it's like a huge area, say like the highway or building infrastructure, so if it's very big or very small, we can still create different virtual reality applications for them. So especially when we want to do training, if we are using the real world training facility, every time you need to spend the money, say for example, like flight simulator or for driver training, train, bus, all the driver training. It is not easy to take them on the road, or every time a pilot is flying for the training, we do not have to waste the fuel. If we create the virtual reality based graphics, then we can repeat it again and again safely inside the room. So and when they are ready, then we do the actual physical training. So with graphics based virtual reality, we can save a lot of money, and also the participant, the user, can try again and again and again, and if they make a mistake, there is no risk or danger. It is still safe. So there are many advantages to these applications. So two of the things that I will try to do today is to show different applications and give specific example of how we can use the approach in a specific application. So in virtual reality, there are different kinds of modes. Desktop virtual reality, and the immersive one, like the cave system, like the iSpace in Fengsha University. The iSpace is an example of a cave system, and there is augmented reality. So there are different kinds of levels of immersion and navigation that is available in the different systems, the different modes. The immersive system gives very good navigation and immersion, but it is very costly. So many universities cannot afford the cave systems. But if you use desktop virtual reality, then all the universities have desktop computers and laptops. So we can use the existing laptops to create these graphics design scenarios. So with the cave, the immersion is high, but the cost is also very high. The maintenance, operation, and installation is also high. So this is an example of GIS cave system. So this is a 1, 2, 3. So I'm using one of the GIS example that I worked on when I was working here in the GIS Center with Professor Tian Chow. This is one of the landscape developed for that, so I just take the example and put it in the cave system. So with augmented virtual reality, we can use the head-mounted displays, the HMDs, and the HMDs do not give very high level of immersion like the cave, but the HMDs are more easy, and many people these days use different kinds of HMDs. So they are easy to use, you can carry them with you, and the cost is not very high. So active learning is a very important technique that is used in many different universities around the world. So with active learning, it is like before many years in the classroom, the teacher just teach and the student listen. But with active learning, the students can interact with what the teacher is teaching. And virtual reality is very useful for that, because you can make one application and then copy it on all the desktops in the lab or the laptops, and all the students can interact with the data when the professor or the teacher is teaching. So the augmented virtual reality is very useful for that. So there are many different virtual reality applications developed. Like I have worked on some of the applications I work on with my faculty members and then my collaborators, GIS applications, programming instruction, manufacturing instruction. So there are many different examples I'd like to show to you. So with the GIS, so in this case we are using the desktop virtual reality. So we have the database, and the database is for each one of the elements, including the shapefiles, the DEMs, the TINs. We can create a virtual reality object, and then we can interact with them with like the touchpad and then the common keyboard and the mouse, and we can have a low level of immersion but a good level of interaction. So with GIS, we still use points, lines, and polygons. So we use points, lines, straight curve, polygons, and then we make the objects. And this is an example using desktop virtual reality. So for students in GIS, when they want to understand the 3D space, the coordinate system, then if we just say them on the board, it is not easy to understand. But if we show them using the 3D, then they understand what is meant by the coordinate system. What is Cartesian coordinate system? What is polar coordinate system? So And also, there is in geometry, in GIS, there is the projective geometry and the Euclidean geometry. So these are difficult for new students to understand, but when they can interact with the 3D, it becomes easy. So some of the applications include, like say, this application is a hardware learning course. So how to learn the computer hardware. And this is an example of the memory card and the graphics card learning application. And this is for the metro station interior design application. And this is a programming application. So all applications are using the virtual reality. So in this case, for the computer hardware, in the real world, it is not possible to go inside the laptop or go inside the desktop computer. But when we use the virtual reality, the students can get inside the laptop and they can actually select. And so if I want to learn about the motherboard assembly, if you want to learn about assembly, desktop assembly, then in the real world, say if there are 100 students in a class, you cannot give 100 computers, one for each student. But if we create this application, then you just put it online or you make this available to the student. The student can get inside and they can access, they can virtually go inside and see, okay, this is where the RAM goes, this is the hard disk, this is where I put the graphics card. And there is no safety issue in the lab because these have electrical components. In the real world, if we allow somebody to use it, they can get a shock or there can be a safety issue. So you always need somebody in the lab. But if you do this, then there is no risk to them. They can just try any number of times, and when they are ready to come to the lab, then they will work with the actual equipment. So all the different components are created, and then there's also a testing. So this show, like say RAM, hard disk, and then the student will drag each one of them in there, and they can learn and test their knowledge by themselves. Okay, that's good. So this one is a screen capture of the actual application. So the student can read about each of the module, and then they identify the basic parts of the computer, and then for every module they take a test quiz on the, so now it shows what each part is about, and then they drag and drop it into the so when they work with the parts, then they complete the module, then they go to the module 2, then module 3, module 4, and then so that way they get to know the parts very well. And if it is only in the classroom, you get to see only once. But if you do it by yourself, you can do any number of times. So with every module, there is a practice test at the end of the module. And then finally, they do the assembly. How you can actually, so if it's a desktop, so this is a simulation, and then how the actual assembly is done, the students can do it themselves. So this is the actual screen capture of a student doing it. So this way, the students can practice all these things any number of times, and then they become as many times as some students do 3 times, some students do 10 times. But you don't need the instructor to be present during this time. So this is the example of so that is an example of one of the applications that was developed using virtual reality, and that example can be accessed by desktop, also the head-mounted display. I click the arrow. Okay. So for the actually mainly I used Oculus and HTC Vive, but Oculus and HTC Vive are little costly comparatively, and they have high system requirement. So now I switched to Dell Visor. Dell Visor is even cheaper than Oculus and HTC. So this is another example of a mechanical engineering example of a remote operated vehicle. The remotely operated vehicle can be used to go below the ocean, the sea, and explore different things like oil exploration, mineral exploration, etc. So this is another example for the assembly of the remotely operated vehicle. So again, this is 3D, the screen capture of a student interacting with the data. So once they create it, then they can translate, rotate, and then they can also interact with the individual components using the HMD or with the desktop. And this application, once created, then all students can use it. So we do not need 50 equipment. We just need to copy the VR application 50 times. Okay, so instead of buying the equipment many times, we just create the VR module, and then the student can actually interact with it any number of times. So in terms of the software, the platform used was X3D and Unity and some Java 3D and scripting, and so we use these to create the 3D worlds for seeing with the Oculus and the HTC and the Dell Visor. So some of the software that's used, the Hydra is used for the interaction, and the Oculus is used for the display, and then we can use the MS Kinect interface for the interfacing between the computer and the VR equipment. So all applications are not equal, means a 3D application is different from a programming application. And an interior design application is different from a game application. So we cannot use the same method for every application. So for a mechanical engineering application, the method that is used is different from a programming application. So when creating the 3D virtual reality, we must work with the expert from the field. So I don't know about, say, mechanical engineering. Then my friend from mechanical engineering, another faculty member, will help with the mechanical part. Then I will work with my students to create the 3D part. So if I am working with, say, a safety application, and I don't know about safety applications, so somebody, another professor from safety will create the safety part, then I will create the 3D part. So every application requires the discipline knowledge, and then you create a 3D part. So STEM refer to science, technology, engineering, math. So there are many STEM disciplines in the US and in India and many other countries in Taiwan too that create many different applications for students for active learning. So some of the applications shown are STEM applications. So the main question to ask is, what should I use? Immersive virtual reality, or augmented virtual reality, or desktop virtual reality? We do not need to use caves for everything. So the question to ask is, what kind of interaction is required? How much money is available? How much time is available? And does this application require immersive, like cave, or is desktop okay? So if you can use desktop, just use desktop. There is no need to use cave. Okay, so the type of the application and the money and the time, that is important in deciding what mode of virtual reality we should use. So this is another application. So it's one of my graduate students. So he created an application for the VR application we created. We also were able to use it on the iPad and other similar devices. So if some kids have communication issues, then this application is for helping them to communicate, to tell what they need. So if you play again, go to the beginning. Yeah. So he's just showing an example. That's my student and that's his brother. He's fine, but they just show an example. So if some children have communication problem, then they can communicate to say what they want. So this is the application that we tested for that purpose. So this is an example to show how, so I'm trying to show different applications, programming, mechanical engineering. So this is an example of biology. So how to show, so quadruped is 4 foot, so biped is 2 foot, like us. So how to show the joints of the animals, and then if we just explain in the book, it's not easy to understand. But if we show the example, then it's easy for the students to understand. And can you please? So now this is a chemistry application. So if somebody wants to learn the molecular structure, then this kind of application can be used for them. And this is something we cannot do in real life because the molecules and atoms are so small, we cannot actually see them. But then with this, the students can actually go inside and they can interact with the bonds, like chemical bonds, molecules, atoms, and this becomes more like fun for them, not boring. So if we show them in the book, then it is boring chemistry. But if we put it like this, then it's more like a game for them. Okay, so those are the advantage with, and if we So this is another example of nanotechnology. So how students can get inside the atoms and the molecules, and they can see the inside structure of the molecules. Nanotechnology is, so when I worked with another professor from Purdue, he's from nanotechnology, he told me that some students have difficulty understanding the nanotechnology, but then we work together and we create some virtual reality applications. Then he used that in the classroom. Then it is more easy for the students to understand, because it becomes more like a game. It is not boring anymore for the students. So this kind of visual presentation, it stimulates the interest and makes understanding easier, and the load on the student is reduced. So it becomes more fun kind of learning. This kind of graphics-based interaction makes learning more easier and more fun, and it helps problem solving and project-based learning. So we look at many different kinds of applications. So I work with different professors, and then first based on the problem, then we develop the visual reality application. So you can, especially one of the big advantage was for the laboratories. Many of the department, they don't have the money to keep making more and more laboratories. They don't have the space inside the university. But we create these modules. We do not use a space. You just put it online, or you make it available to students on the course website. Then the students can access this, and the students can also buy their own HMDs, or they can be given HMDs, and they can practice it at their home or wherever they are. So some of the important things that need to be done for the visual reality, for the interaction, is to program the user interaction, and then the event-driven, like say when you click, left click or right click, or if you click and drag, or if you hover the mouse. So we can, and then many of the keyboard shortcuts, we can use this for driving the interactions. So this is another example of a programming example project. So I have that much time, so I'll try to wrap up. So the basic idea is to show the concept of arrays, and then use a game of chess to explain some logic in programming. And this is the conditional. So how many times the ball keeps going around, and then tic-tac-toe to show the looping and the if-else conditional, and if-else. So we use many different kinds of graphic applications to demonstrate programming logic and fundamentals to students. So, and also this is an example of the game, how to use the games and both 3D and 2D to create the concept of programming. Okay. So finally, we saw different kinds of examples, and the last time one of the presentation I made for the GIS Center, the last time was how we can use the virtual reality for natural disasters, and then so there are many different kinds of applications that have been developed for virtual reality. Okay, so conclusion, This kind of application can be used not only for GIS, for many different disciplines. So by working with many different professors from many different research people and by working with the GIS Center, I apply it to different areas and develop the 3D virtual reality for different applications. So the results have been quite effective. Finally, the VR framework helps better understanding, and if we are using it for, like, say, disaster preparation, once again you can simulate the disaster, like debris flow or earthquake or seismic activity or typhoons, etc. And so, questions, I hope I'm on now. Thank you. Have any questions?
OK， 我们很谢谢Prof Magesh 的一个今天的介绍，关于 desktop VR。我刚刚一开始也介绍Prof Magesh，他其实对于亚洲、对东南亚相当的了解。普渡大学，他们现在目前有一个电脑绘图技术的研究室，他现在目前在这个就是在主持。所以刚刚的演说里面。也提到了非常多所谓的 desktop 的一些 VR 的技术怎么去运用。多年之前，其实我看过Magesh 他在建一个 building 的 model， 那他跟我们在建的概念也不大一样。我们建的概念是我们用画，或是用滑鼠，或是用 TGIS 这样的方式去描述，或是 photo， 然后去描述那个一个建筑物，就是立体的建筑物。它的描述方式是。它每一个直线、弯线、圆圈是用数学方程式去表达，就是他去写一个 y 等于什么什么 x 加上 exponential 的多少次方，把这个东西写出来，那个图就出来了。然后另外一个物件，他是在写一个程式，所以他每个物件都是一个程式的把它画出来。第一次我就看他这样做，惊为天人，因为我们要去弄清楚这程式到底代表什么意思，程式画出来是什么样的图形，那是个立体的，那个其实要想很久。所以我看他程式，我还不一定想得出来这个画出来是什么样，但他直接就。打出来，打完之后这一栋建筑外观就出来了，所以非常多年之前就看到他这样来做。那他最近这几年在整个VR这个办公室里面主持，他们其实在全世界，普渡大学在全世界推广像 desktop VR 的一些教学，甚至一些合作。所以他这次来台湾，其实普渡大学这边也希望在做一些教育的推广，甚至跟产业界的合作。普渡大学跟他们在，因为Magesh本身是印度籍，所以他们在印度普渡大学那边也有一些合作的厂商。然后这次来也希望跟国内的产业界可以多多的沟通，来谈谈看有没有机会，不管在国内，甚至国内有没有产业界，跟印度的方面一些产业希望能够合作。我想这也是一个非常好的契机。Magesh也会在这边继续再停留几天的时间，所以他在会场的时间，欢迎各位有机会可以多多跟Prof Magesh沟通一下。因为这是专题的演讲，所以我们大概就开放一些所谓问题的一个方式。但各位有任何一些事项想要再多请教，非常欢迎直接跟Prof Magesh 这边接触。Well, I think it's a keynote speech, so we won't have any time to like questions scheduled for you, but. If there any person is interested, yeah, they can come to you directly. Thank you. So, 我再一次感谢。